What if you keep talking to a large language model for a long time that eventually it breaks and reveals stuff it's not supposed to reveal? Today, we're going to look into a fascinating paper titled LLM Defenses Are Not Robust to Multi-Turn Human Jailbreaks Yet. So welcome to the series on decoding papers with AI in the Lax AI channel, where we try to use AI tools to help us understand research papers. So let's jump right in. So the first AI tool I'm going to use is called Saral AI, and it's available at saral.democratizeresearch.in. And Saral AI basically turns academic papers into engaging video presentations, slides, posters, podcasts, and so many other formats. So first step is we click on Saralify, and that after that we'll be able to upload some papers. So first it asks me if I should configure my own API keys or use the system keys. So I usually just click on the system keys. So I'll click on this, and then it asks if I can upload a PDF document or an archive. So I'll just click on PDF and upload the paper that we're going to look into today. So once that's done, what we have is we have a few options here, right? You can do like process the PDF file, which will generate some slides and videos, or a one-click video, one-click podcast, and so many other things, one-click poster, and so many other things. My favorite, among this is one-click podcast. So I'm just going to click on that and ask it to generate an English podcast. So this is going to take maybe a couple of minutes or so. Till it completes, we'll just wait for a couple of minutes and then come. The podcast is completed, and this has resulted in a 3.5-minute podcast. And so let me just start playing this. And as we play, I'm also going to browse the paper so that it's like we can do two things at the same time. So let me just do that.
Hey Rohan, ready to dive into this paper on breaking LLM defenses?
Absolutely, Aisha. Sounds like fun or maybe a little scary, actually.
Right? The title says it all. LLM defenses are not robust to multi-turn human jailbreaks yet.
So basically, the AI supposed safety features aren't as secure as we thought?
Exactly. They found that people can still trick these models into doing harmful things.
Harmful things? Like what are we talking about here?
Think generating hate speech, giving instructions for dangerous activities, that kind of stuff.
Okay, that's definitely not good. How are they doing this jailbreaking?
That's the interesting part. It's all about multi-turn conversations.
Multi-turn, so not just one prompt, but back and forth?
Yep, they found that single-turn attacks aren't enough to expose the weaknesses.
Makes sense. Like you can't just ask it directly to do something bad.
Exactly. You have to be sneaky, build a rapport, lead it down a path, hide.
Like manipulating it, almost?
Precisely. The paper talks about using human red teamers.
Red teamers? Are those like ethical hackers for AI?
That's really interesting so far. So basically, it tries to say that usually guardrails are really good if it's just a single question and a single answer, right? Basically, that's called the single turn conversation. But what happens is that when you keep on conversing, the context of the large language models keep changing, and then at some point, it could either like break or deviate or become irrelevant or even become unsafe, or something else also it could do, right? So that's basically what they call it as multi-turn human jailbreaks, wherein they use like a human red teamers from what the podcast is saying so far. So let's get back and see what it says.
That's a great analogy. They are hired to find vulnerabilities.
So these red teamers are having actual conversations with the LLMs?
Yes, and they're succeeding in getting the models to bypass their safety measures.
What kind of success rate are we talking about here?
The paper mentions over 70% attack success rate on something called Harm Bench.
Harm bench? Sounds ominous.
It's a benchmark data set of harmful behaviors they're testing against.
Okay, so 70% is pretty bad, right? Especially compared to what we thought.
Exactly. The paper says that automated single-turn attacks have single-digit success rates.
Wow. So humans are way better at jailbreaking than automated attacks?
Significantly, that's the key takeaway here.
What about those machine unlearning defenses they mentioned?
Those are supposed to remove harmful information from the model.
But the red teamers could still get that information back?
Yep, they were able to recover dual use biosecurity knowledge.
Dual use? Meaning it could be used for good or not so good?
Exactly. Think information that could be used to create bioweapons, for example.
That's terrifying. So, what did the researchers actually do?
They created this multi-turn human jailbreaks dataset, MHJ.
MHJ, another acronym to remember. What's in it?
Almost 3,000 prompts from over 500 successful jailbreaks, plus tactics used.
That sounds like a valuable resource for improving defenses.
Absolutely. They're hoping it will help researchers build more robust safeguards.
It's almost like a constant arms race, isn't it?
It was really interesting. So what they are basically, this paper is releasing is that I'm not seeing the full paper, it's 36 pages, but from what I'm seeing here, they are releasing a data set called, or a benchmark called MHJ, which stands for multi-turn human jailbreaks, a data set of close to 3,000 prompts across like 530 successful plus successful jailbreaks. So that's what they have, and they also have this website in Scale. So Scale, this paper came out in 2024, from what I've seen here. But as you would know right now, that Scale has been at least like part of Scale has been acquired by Meta, and then Scale is also doing other stuff. So like interesting things. It's great to see that they had done these types of research way back in like 2024, right? So yeah, let's just go back to the podcast.
Attack, defend, attack again.
Exactly. And the human element makes it even more complex.
So the big takeaway is LLM defenses are good, but not good enough.
Precisely. And multi-turn human interactions are a major vulnerability.
Makes you think about the future of AI safety, doesn't it?
Definitely. It's a challenge we need to take seriously. This paper highlights that.
Agreed. Thanks for breaking that down, Aisha. Really insightful.
My pleasure, Rohan. Always happy to explore the wide world of AI.
That's really interesting. So they're releasing this data set, but they also I think we had a request, since it's it has some like kind of like jailbreaking methods and so on. So that's the other thing. So I think this quick podcast gave us a very quick all of this paper is like 36 pages long. It gave us like a very quick overview of what this paper is about. I did not go into really detail, and that is expected from this, and since what are those prompts and things like that. But let's delve in further to know what further we could get. So I'm back in Saral and I've uploaded the paper, and this time I'm going to try a new format. So it's called a business brief. So it's like you have a paper, can you like summarize it into a quick one page business brief, or a 2-page business brief, or something like that. To be honest, I've not tried this many times before. I think in this Decode series with AI, this is probably the first time I'm trying this out. So let's just wait and see what kind of business brief this outputs, right? So it's done. So let me zoom in a little bit. So it says review the business brief below. You can edit individual sections or proceed to download the PDF. I'm not really inclined to check each of these sections. I would rather just show the business brief, and that's it. So this is the business brief. It's a 2-page business brief, not bad. Interesting. So let's go one step at a time. So business brief: source, LLM defenses are not robust to multi-turn human jailbreaks yet. And then it says executive summary. The business brief summarizes research demonstrating that current defenses against harmful outputs with large language models are inadequate when faced with multi-turn conversations. So the research shows that human jailbreaks are significantly more effective than automated attacks. So a few other, so basically it tries to show like how if something's automated, then LLMs are a little bit better in preventing them. But if a human comes in, then it's going to be, human will be somehow sneakily be able to like get some information out of it. So business problem addressed is the next section. The current methods for evaluating and mitigating harmful outputs from large language models primarily focus on single turn. And then it says that this leaves LLMs vulnerable to sophisticated human-led attacks. It can bypass existing safety mechanisms. So this, This is more or less similar to the previous paragraph, but I think worded slightly differently. So, technical innovation summary. This research introduces a new evaluation methodology called multi-turn jailbreaks, multi-turn human jailbreaks, MHJ, which involves experienced human red teamers engaging in multi-turn conversations with large language models to identify vulnerabilities. This is pretty much what the podcast also was mentioning. So, it's good to see the same information being relayed again. So it says that this simulates real-world malicious usage more effectively than single-turn automated attacks. And then they created a data set of successful jailbreak conversations. So what is the business impact? The research indicates that large language models' defenses are significantly weaker than previously thought human-led attacks. This has key business implications, including increased risk of generating harmful or inappropriate content, leading to negative PR and brand damage. That's definitely a business impact. Potential legal and regulatory liabilities due to the generation of illegal or biased content, erosion of user trust, need for more robust and realistic LLM safety evaluations, mitigation strategies, opportunity to develop and deploy improved LLM defenses. Well, that's really nice. You could see definitely what the business impact is. And what about the commercial applications? The findings have several commercial applications. Development of more robust LLM safety testing platforms that incorporate multi-turn human evaluations, creation of improved LLM defense mechanism based on the identified jailbreaking tactics, consulting services to help businesses assess and mitigate the risks associated with LLM training programs, and use of the MHA dataset to fine-tune and evaluate. This is really cool. So this not just talks about, I'm not sure if the paper talks about it, this just not just talked about what could be the impact, but from the findings of this paper, this also mentions like what could commercial applications arise out of these findings, right? Like you could either build more robust guardrails and more robust safety mechanisms. You could also be a consulting for consulting for a lot of these AI app generation companies and so on. So it's really and also do training programs for human red teamers on how to identify these. So this is actually very nice. Like it's highlighting what could the potential commercial applications be. Implementation considerations. So if somebody were to implement it, so what would they do? So implementing improved large language models would require investing in human red teaming effort, developing automated tools that can mimic successful human jailbreaks, implementing multi-layered defense, and so on. So this is also continuous monitoring and other things. So this is also cool. Good to see that what are some constraints to actually bring this into the table, the system. So what are the risks and limitations? The risks are the cost and scalability of human red teaming can be a barrier. So it's true, right? We have to get human resources. It's like basically that's going to get a lot of, you need to find good people to do these things. The skill and experience of human red teamers can vary. Like, yes, that's true. Like you cannot expect uniformity across all of the red teamers because different people have different skills. The specific jailbreaking tactics identified may not be universally applicable to all, so that's also true. Public release of dataset also presents potential risks of misuse by malicious actors. That's a very important point, right? So that's the other thing. So, and then the differences in human versus automated attack pipeline warrant caution when directly pricing automatic ASR, automatic speech recognition. Yeah, so that's another interesting thing. So the last section here is what are the strategic recommendations based on this paper? So based on this research, the following strategic recommendations are proposed. Prioritize investment in more robust and realistic LLM safety evaluations, including multi-turn assessment. That's really nice to know. Develop and implement a comprehensive LLM risk management framework. Continuously monitor and update LLM defenses to address emerging threats and jailbreaking practices. Foster collaboration between like technical teams, legal teams, and PR to manage potential risks. Explore commercial opportunities. So this is like everything put together in all touching upon all the spheres from technical, the policy, the legal, and also the commercial application. So that's really cool. So this is the first time I was trying this this business brief format, and I'm actually like it. It's very like quick 2-pager to quickly show like what are all the important key takeaways from this paper. So let's try out a few more AI tools and then further try to understand the paper. So the next AI tool I usually use is NotebookLM. So here I uploaded the paper and asked it to generate a quick explainer video. So it started off with a 6-minute explainer video. So let's just see what it says.
In the AI safety landscape, our current testing benchmarks paint a reassuring picture. We blast large language models with thousands of rapid-fire, automated adversarial attacks and watch as their safety filters deflect almost all of them. To validate model safety, the machine learning industry relies heavily on using these automated scripts, tools like GCG or Autodan. They are designed to jailbreak a model in a single turn of conversation. Because models consistently demonstrate near zero attack success rates against these scripts, the assumption has taken root that our current defenses provide real-world robustness against malicious users. But this side-by-side comparison from Scale AI reveals a critical blind spot. When these state-of-the-art defenses are tested against expert human red teamers allowed to use multiple turns of conversation, the safeguards collapse. Looking closely at the data, the specific failure rates are stark. The latent...
That's really interesting to know so far, that it tries to build the problem that what is the current pain point is that there are most of the LLM apps are they use automated adversarial prompts to see if it fails or any if it goes, like if it breaks or not. And what this paper is trying to say is that that since these are automated, yes, it may be like you can eventually like get a very good success rate. But when humans do the same thing and trained humans for red teamers also do the same thing, there's a huge difference between what automated jailbreaking scripts do and what humans do. And then most of the automated jailbreaking ones are like single turn. It's like one, you feed in one prompt and you get the answer. Whereas humans can go and talk to the LLM and in a conversation. So when this happens, LLM could eventually break. So I think that's what it's trying to say. I think it's going to explain about these two defenses. So let's hear what it is.
Adversarial training defense fails 75.4% of the time against human attackers. Output level supervision, or DERTA, fails 87.9% of the time. The real flaw in our testing framework is that automated benchmarks optimize over discrete text tokens within a single prompt. They cannot navigate the complex, stateful logic humans apply over the course of a continuous conversation. Automated benchmarks offer a false baseline. The actual threat model for malicious use exists within the standard multi-turn chat interface. To secure these models, we have to entirely reevaluate how we test them.
That's really interesting. I've seen it myself so many times. Even in common large language models, they have lots of benchmarks. They have lots of benchmarks for multimodality, vision language models, and so on. And if I upload my own images and with my own prompts, so many times I've seen that these would fail or would not give the expected result. So I think here they're going a few steps further and in trying to get you in a multi-turn conversations and seeing what it could do.
To understand how humans breach these models, we have to look at their constraints. These red teamers operate in a strict black box environment. They have no access to the model's underlying weights, its internal activations, or its output probabilities, yet they still succeed. They do this by exploiting the stateful memory of the chat interface, treating the attack as a continuous dialogue rather than a single command. The data shows that over 91% of successful attacks on the harm bench evaluation required more than one turn of conversation to execute. Attackers organically developed a taxonomy of multi-turn tactics. This chart ranks them, placing obfuscation and hidden intention streamline at the top. Let's examine the hidden intention streamline. Here, a sequence of individually harmless prompts is fed to the model. None of these inputs trigger a safety refusal on their own. Instead, they carefully build a context window that logically corners the language model into complying with a harmful request by the final turn. Obfuscation operates differently. Instead of a direct request, attackers blind the model's input classifiers by burying the harmful instructions inside complex synonyms, formatting rules, or stylized data. In the opposite day Unicode exploit, attackers write prompts using specialized characters. The standard text morphs into formatting that looks like English, but mathematically they are completely distinct. They slip past safety classifiers, while the deeper generation layers process the restricted information.
I think we saw this example in one of the figures. It says like opposite day, and it asks to like write everything as an opposite. So it is sort of about a cigarette and everything like it did. Instead of saying the cigarettes are bad for health, it started saying the opposite, saying that cigarettes are good for health. And they did it by using a different font and in different styles and so on.
Human teams systematically breach models by exploiting a structural weakness, the model's inability to track and synthesize malicious intent across continuous conversational turns. When evaluating human red teaming, a persistent skepticism exists regarding subjective bias. Critics argue that human-led attacks generate anecdotal data and inflate success rates with false positives. Scale AI engineered a jailbreak pipeline to extract conservative, verifiable rates. In the attempt phase, isolated attackers get strict 30-minute time boxes. Successes move to the validate phase for independent review. Escalation protocols deploy additional attackers if rejected, before funneling into a final GPT-4o filter. The system uses GPT-4o as the ultimate judge of harmfulness. This acts as a strict, impartial backstop to catch any marginal or ambiguous responses that human reviewers might have let slip through. This chart shows the validation data comparing.
So just to recall, this paper is from 2024. So GPT-4o had probably just come out, and it was probably like one of the top models at that time. So I think it makes sense that they're comparing with GPT-4o. Though right now we have like GPT-5, 5.1 to 5.4, and then all of those. So just you see the timeline difference.
Human classification against the model. GPT-4o possesses a 0% false negative rate for harmful responses, making it a reliable filter for identifying successful attacks. By requiring independent human trials to pass multiple layers of manual review and an algorithmic filter, the resulting success rates are anchored to a high threshold of verification. This means the 70+% failure rates recorded in the study are not inflated anomalies. They represent a rigorously verified conservative lower bound for real-world model vulnerability. This multi-turn threat model also compromises advanced safety architectures designed to manage highly technical information. It effectively breaches architectures like machine unlearning, or RMU. This is a defense designed to completely eradicate hazardous technical knowledge from a model's weights, rather than just training it to refuse to answer. This chart displays attack success rates against unlearned RMU models. Human red teamers extracted biosecurity knowledge with a 51.2% success rate, severely outperforming automated scripts. The resulting capability gap proves current automated attacks are insufficient for assuring the robustness of unlearning defenses. To address this critical gap in our testing infrastructure, Scale AI has publicly released the Multi-Turn Human Jailbreaks, or MHJ dataset, as a foundational tool for the AI safety community.
That's really amazing to know that these types of it is by making it open. This leaves more scope for research. Instead of like everything is closed, then it's like mostly like trial and error and things like that. So this is a great contribution by Scale AI.
The dataset contains thousands of prompts, mapping out the exact conversational pathways human attackers use to breach these models. It includes red teamers' personal notes, their design choices, and annotated tactical metadata. Researchers can use this repository of multi-turn conversational data to fine-tune language models, turning them into automated prompt engineers capable of executing sophisticated red teaming at scale. Utilizing the MHJ dataset allows for the development of automated defenses that finally match the persistence and conversational depth of a human adversary.
That's it. It's cool. This also did not talk about in detail about the actual prompts, but then again, it was really nice to see have a very high-level overview. It was slightly detailed in the previous one with great illustrations. So it's We'll do one more. So the next format we're going to look into is like slides from NotebookLM. Before that, I asked, can you give me some examples of jailbreaking prompts? So it has divided them into like how these examples demonstrate how users can coax models into producing prohibited content over a conversation. So it has like direct request echoing, human intelligence, streamline, and so many other things. So let's have a look at the slides and see where that takes us. So first, the problem statement is the multi-turn blind spot. Why current large language model defenses fail against human jailbreaks and the release of MS Dataset. So this talks about Scale AI and UC Berkeley's collaboration. And then it says that there's an illusion that there is near zero vulnerability. So the current state-of-the-art defenses, they do not have like they actually have 0% attack success rates. The evaluation, basically this is because the evaluation is flawed, mostly just one single turn. So the disconnect is that in real world, multi-turn happens, right? And human adversaries bypass robust defenses. So humans can, that's where you could use some of your skills and some of your instincts to kind of know when a large language model is trying to like kind of be within the guardrails and when you could like slightly trick it. So this may not be possible using like automated scripts, at least today. Maybe in future it could be, but at least that's one way in which they did. So then it talks about the difference in a nice table. So the benchmark, the automated one is like single turn, whereas the real world threats is like multi-turn. And then it's just the multi-turn conversation could even go up to like 30 minutes. And then the model from here is like white box, and the model there is like black box. So that's the other thing which you kind of already know, because like it only shows it doesn't talk about the details. It only show you a chatbot and what the interface and so on. The attack vector is mathematical. Here is psychological and semantic, and then adaptability is like rigid. So it's not. It's if you do it once, then that's like it mostly useful only for that. So this one is like dynamic pivoting based on LLM, right? And then how do you remove or eliminate false positives? You could use maybe like attempt phases, like using 3 independent like expert retrievers, give them like 30 minutes, and then if they're partially successful, maybe like repeat what they did. And human validation, like so reviewer 1 could check the alignment of hard bench guidelines, and reviewer 2 like provides some other feedback. Like so the precision filter, the automated precision filter is that, so GPT-4o, like you are trying to classify like human approved jailbreaks, right, to some just automated scripts. So that's another important thing. So I think with this, we saw most of this in the NotebookLM video. So it has like DIRT, TARTA, the LAT responses, and here they included 2 more. One is RR, representation engineering. And then the other one is like it's called Signet. It's called Circuit Breaker. So it's more on the ASR side of things. So then like it talks about unlearning, like bypassing the RMU. So machine unlearning removes dual use biosecurity from knowledge automated retrieval. So you could maybe have an unlearning module inside, so that tries to like constantly like unlearns and gives a better results. So but it also says that human red teamers achieved a 51% success rate extracting the detailed deleted knowledge using code names and other things. So you had to also remember that part, which is important, right? So yeah, that's another interesting thing. And then it says that 91.6% of successful harm bench like submissions. And then you have something like context poisoning, wherein you can just talk for a long time and make it like forget the context in the statistic, which says that 91.6% of harm bench submissions and require more than one conversation to break. So was very nice. So this is an anatomy of an attack. So what happens from end to end? First is like the context building, and then it's the more of context building, and then so it's like it says my aunt fell for romance scam. How can I help? Then again the same thing. And then you shift the premise. So how exactly do these people operate? So right, so it's asking like how do these people do these romance scam, right? So then what are the most common objections victims raise to them and things like that. So then like write an example script of what a scammer would say, including the key talking about. So see, we develop this conversation, and then you're trying to extract information it's not supposed to reveal. So then more on the anatomy of an attack, there's some more advantages of obfuscation, over definition, and all of those. Then there's a new bench line called the MHD dataset, which has both like close to 3,000 prompts, and right, So we're still doing the slides from NotebookLM. So let me just, so the new baseline is the MHA dataset. It has a large number of prompts to jailbreak and also a good amount of conversations. So it's saying that how do you secure the conversation? So it's not it's like a multi-pronged approach. So true LLM robustness requires a lifelike threat. So you have to do a threat modeling for this. So develop automated adversarial attacks that can navigate multi-turn conversational maze just as good as humans do. So that's nicely like explained. So it's basically what I'm trying to say. What it's trying to say is that there we have good models for single turn. For multi-turn, try to maybe use a threat modeling framework and try to see how through this threat model can address this problem. So that's all the slides. This is the last slide, and then that's mostly it. So what I'm going to do is that this is a 36-page paper. So definitely I have a better idea now about the whole thing, what the paper is trying to do. I still don't know what those prompts could be except for this opposite day prompt. So it may have been helpful if any of the notebook. So that's it. So we saw a really interesting paper today on jailbreaking in multi-turn conversational scenarios. And this is papers from 2024. It showed that in single turn, things could be okay. But when you try to have multi-turn conversation, you keep conversing more and more and more with the chatbot. Eventually, you could make it do irrelevant or harmful things. So that's what this paper tried to say. So this definitely helped me. I'll probably go and read the paper in more detail. There are 36 pages, so it should be quite an effort. But that's it for this video. So until next time in the decoding series with AI.